All right, everybody, welcome back. In this module, we're going to actually go through and learn how to interpret the findings from our logistic regression. In the last module, we actually talked about what to do with our outcome when it's not continuous. We introduced what a logit regression model is, and today we're actually going to talk about how to interpret our findings once we've fitted the logistic regression in R. So to start, I just want to remind you of the example that we used from last time where our outcome of interest was CHD, or coronary heart disease, and the main predictor that we were using was age. And as a reminder, here is how we imported the data into R, and here I'm running my Logit model where CHD is the outcome, age is the primary predictor, the CHD data is my main data frame, and here, remember the family of regression models that I'm choosing from is the binomial with a logit link. So now that we have our model, let's take a look at the estimated coefficients. We can see that our estimated coefficient for the intercept is negative 5.3, and our estimated coefficient for age is 0.11. So just remember those for moving forward when we're actually constructing the regression fit. So now that we've actually got our estimated coefficients, what do we do from here? Now, remember, when we're actually estimating the logistic regression model, the fitted regression, right, when we're looking at what is the probability of having CHD over the probability of not having that, when we take the log of that, right, we are literally getting our fitted regression line here, where we can plug in our estimated beta coefficients, right? So here what we're going to do is just plug in our estimate of the intercept as well as our estimated relationship between age and CHD. So we have negative 5.3 and 0.11, right? Now, let's say we want to actually solve for what the probability of having CHD is, right? So if you remember correctly, we're interested in getting the expected probability of having CHD given some value of X, so some age, right? That's equal to, like I said, the probability of having CHD given that covariate value, let's say 50 or something for age. And the way we're going to transform this, right, is taking the exponent of the top part here, if you remember this, right, which is just negative 5.3 plus 0.11 and whatever our value of X is over this 1 minus the probability, right, of having CHD, which is going to be 1 plus that exponent. Now, the nice thing is that this value on the right is going to be bounded between 0 and 1, right, because we can only have probabilities that are bounded between 0 and 1. And this is also because our beta 1 is positive. This means that as X is getting larger, the probability of having CHD goes to 1, and as X gets smaller, the probability of having CHD goes to 0. And this makes sense, right? So we know that as you increase in age, your risk of having heart disease goes up. And we can see this visually if we actually plot out the fitted values that we get when we're looking at the expected value of, or the expected likelihood of having coronary heart disease at a given value of X. So here, all I'm doing is setting up the plot where my X is the values for age. Here, I'm putting a jitter so that you can see what the underlying observations are, the underlying data that the model is being generated from. Here I'm adding the points of the fitted binomial regression. So these are actually the predicted probabilities here, or the expected values of Y given a certain age. And I'm just adding a curve between these points to help show visually. So here, like I said, we can see that for lower ages, we have a lower predicted likelihood of having CHD. And as our age increases, we can see that the fitted line does correspond to the actual functional form of the logistic function. And This is actually part of the assumptions that we're building into the model, right? So we could imagine that if we are using a different type of function, we would have a different fitted line here. And that's something that we're going to talk about in our next module with regard to how well does our data fit actually the logistic function, and should we be using this as our actual underlying distribution in the model.